Hello everybody, my name is Rehman Zafar. I'm from Cookmin University. I'm going to present about the paper titled as Hybrid Long Short-Term Memory Recurrent Neural Network Approach for Day-Ahead Solar Irradiance Forecasting for Power System Scheduling. This is the outline of my presentation, which includes introduction, methodology, experiment and results, and conclusion. So let's move to the introduction. The renewable energy, especially from PV, is considered vital in order to deal with the environmental and social challenges such as carbon emission and energy shortages. However, it creates unscheduled uncertainties which can cause the reliability and stability issues in the energy systems because of intermittent nature of the solar irradiance. So this variability in the solar irradiance can affect the planning, management and operation of electrical systems. So therefore it is very important to predict the power output from PV with effectively with high accuracy. So the highly accurate prediction system can lead us to a secure and optimized solution. So in this paper we have proposed a forecasting framework for solar irradiance data. So we used a hybrid approach with deep recurrent neural network, LSTM, recurrent neural network with unsupervised clustering. First we do the clustering and then we move to the LSTM recurrent neural network model. So in the further slides we will talk about it in detail. So we didn't use a conventional recurrent neural network because it is because of the problem of vanishing gradient. So if we have long data, then the gradient get vanished. So to solve this solution, the researchers have proposed LSTM. So we used LSTM instead of conventional recurrent neural network. So here you can see on the right side the LSTM unit, which has the different gates, different logical gates that can be used logically, depends on the current time step, whether we have to use the previous data or not, because it stores the information of the previous time steps in the time series data. So for the PV output, definitely we need solar irradiance. So we put the solar irradiance in this formula and get the output of the power solar power plant or solar cell. So it has like different parameters which can be different for the different technologies of solar cells. So the main thing is the solar irradiance. In this formula we will put the solar irradiance and get the power output of the PV. So there are many hybrid artificial intelligence model in the literature that has been used for forecasting the renewable energy resources. These hybrid systems work like first they use clustering method to classify the data and then move to the main forecasting algorithm. So there are different kind of classification methods like unsupervised and supervised uh, algorithms such as support vector machine, k-means clustering, and k-nearest neighbors. So after classification, like I said, they use the main forecasting algorithm. So similarly, we have used the clustering approach, and then we use the main algorithm, that is LSTM recurrent neural network, to improve the forecasting. So we will see later how our results gets improved by using the hybrid model. So first we classify the data into two clusters. In our approach we divided our days into sunny and cloudy days by k-means clustering, which is unsupervised learning. So we classify the data, and with the k-means clustering we get the average, lower average data, which is went to the cloudy day, and the higher one goes to the sunny day. And then we used LSTM RNN approach, means we used our sunny days and cloudy days models separately, and we trained the model. So this is the overall structure of our proposed methodology. We have historical data, then we distribute the data into training, validation, and testing set, and then insert into the clustering algorithm, which is k-means clustering, and then we have sunny day and cloudy day, and then we train and validate and test the data for both the days separately using LSTM RNN. On the right side you can see the LSTM RNN architecture. We insert the data here with exogenous features, and then it goes to LSTM units, layers, and hidden layers, and then finally on the output layer we will have solar irradiance for both the sunny days and cloudy days. So let's move to the experiment and results section. So to demonstrate the effectiveness of our forecasting model, we have used the data set from USA for 12 years, from 2006 to 2017, from which 10 years we have used for training and 1 year each for validation and testing the model. So we trained our model on LSTM model on cloudy and sunny day separately. So in this experiment, from many features we have used humidity, dew point temperature, and dry bulb as of exogenous feature. So for parameters, we have used learning rate 0.004, the solver Adam and SGDM, and then we use 3 hidden layers to make it the network deeper, and 24 hidden units. And for the normalization of the data we use standard scalar. So here we can see the results of our proposed model, which is compared with the persistence model and the feed forward neural network. Persistence model is like we have the values of the SEI same as on the next day. So we can see that on various evaluation matrices the LSTM performs better than other models for both sunny and cloudy days. So similarly, from graphs we can see that the hybrid LSTM results are very close to the measured results. So in conclusion, we have proposed a hybrid LSTM RNN approach, which is proved better as compared to the other methods, considering feed forward neural network and persistence, even for the approach without clustering. So we can see that our results are less than 5% in case of normalized root mean square error. If we compare with the method without clustering, so we can see the difference between the RMSE of around 20 watt per meter square. So we can conclude that the proposed forecasting framework would perform better than other forecasting algorithms for scheduling the power systems and overall operation. So here are the references we have used in this paper. This is the end of my presentation. Thank you very much.